looking at lesson 6.1, graphing of quadratic functions. Remember, when we're talking about a quadratic function, we are looking at it in the form of ax squared plus bx plus c. We're looking specifically at problem 22. And problem 22 asks us to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Make a table of values for this, and then go and graph it. The y-intercept is always going to be your c value, which is a -5. The axis of symmetry is found by using the equation x equals a -b over 2a. My b is a -4, so I plug in a -4. My a is a 1. Simplified up, my axis of symmetry is x equal to 2. The coordinate of the vertex, the x value, is going to also be 2. Those are the same value. So when you find your axis of symmetry, you also find the x value for your vertex. Now, the nice thing about these is when you're talking about a parabola, they're symmetric. So start off with your vertex. Plug that 2 in. So I get a 2 squared minus 4 times 2 minus 5. I come up with a -9. Take some more values. Use your graphing calculator to help you find some values. We already know that our y-intercept is at -5. When I plug in a 1, I come up with a -8. And because they're symmetric, I can go in and find out what the 3 is. It's going to be a -8. And when I plug in a 4, I also get a -5 because there's the symmetry going on around the vertex. Coming over to the graph to graph it, I'm going to count my by ones. I'm going to put my y-intercept of -5 on there. I have the point -1,8. I have the point -2, excuse me, 2 -9, excuse me. I have the point 3 -8 and the point 4 -5. And I draw in the parabola. Moving on to the next group of problems, we're asked to determine whether each function has a minimum or maximum value, and then find out what the value is. You get the maximum or minimum by looking at the a value. In problem 34 of f of x is equal to x squared minus 8x plus 2, a is a positive value, which means it is going to open up. Because the graph opens up, I'm going to have a minimum value. And I'm going to find that minimum value by using the -b over 2a. When I find that value, I plug it in to find out what the y value is. The y value is going to tell me what my maximum or minimum is. So plugging in, I'm going to -8 all over 2a, which is a 1 for the a. Simplifying up, I come up with a value of 4 for the -b over 2a. Now I take that 4 and I plug it into my quadratic equation there, the quadratic problem I have. And when I simplify up, I get a -14. So my minimum value is a -14. Problem 39, you have to be careful of on this one, because when you look at it, you're given x minus 2x squared minus 1, not standard form. You want to put it in standard form so that you can see your a, b, and c values accurately. So now I have a -2x squared plus an x minus a 1. Because my a is negative, it's going to open down, which means it has a maximum value. To find that maximum value, I again have to plug it into the -b over 2a and then find the y value. So my b is a 1. My a is a -2. When I simplify it up, I get a positive 1/4. Now I need to take that 1/4 and I need to plug it into my quadratic equation. And simplify it up. So when I simplify it up, I come up with a -7/8 for my maximum value. And the last problem is a story problem. These two go together. We have a tour bus company in the historic district of Savannah, Georgia, serves 300 customers a day. The charge is $8 per customer, but the owner estimates that the company will lose 20 passengers a day for each dollar increase that they do. And our job is to try to find out what should they charge so that they can maximize their profit, and once they charge that, what would their maximum profit be? So we're going to identify the variable. X is going to be the number of dollar increases. Now when we're looking at it, we are dealing with people and we're dealing with cost. So we're going to come up with two binomials. One is going to deal with the cost. One's going to deal with the customers. The cost is going up, so I'm going to take that $8. It increases $1 for every increase I have. And the customers of the 300, I'm going to lose 20, so I'm going to take a subtract 20 for every increase I do. We're going to use our FOIL, put it into standard form. I come up with a negative 20x squared plus 140x plus 2,400. Now we have our quadratic equation. I fill in and do my negative b over 2a to find out my x value. How many increases do I need? So I take a negative 140 all over 2 times a negative 20. Simplifying that up, I come up with 3.5. So we're going to do 3.5 increases. Now each increase is $1, so that means I'm increasing it by $3.5. So my price was 8. I increase it by 3.5. I now need to charge $11.5 to maximize my profit. Then we're asked to find out if the company raised it, what would be their profit for it. So we're going to take that negative 20. We're going to plug in that 3.5. Take the 140, multiply that by the 3.5, add the 2,400. All we're doing is substituting in. And when we calculate it out and substitute it in, we find out that the company would make $2,650